Now that we've seen how Starlette handles HTTP by leveraging Python's async await, I want to look at how Starlette leverages async await to handle WebSockets. So this is something that Django is not built to do. So Django doesn't have the async await. It's built in what you might term regular Python or synchronous Python, and it is therefore not in a particularly good position to handle something like a WebSocket. On top of that, Django is built very much with HTTP in mind, right? It expects that you're going to have a connection with a request, it does whatever it needs to, and then it immediately responds. This is very different from WebSockets, which are built as a solution for persistent connections. The goal here is that there's a piece of JavaScript in the browser that is going to connect to a WebSocket, and then it stays connected. And you can have multiple messages that go back and forth. Because Django is not architected for this, it is not set up to be able to handle this. One of the lovely things that we'll see is that Starlette is architected to handle this and is able to do so quite easily because of Python async await. Back in my terminal, you can see that I've opened two files side by side. Over here, I have URLs, and as we have previously seen, there is down here a WebSocket route. The WebSocket route refers to sockets and is pointing to an endpoint that is built in Starlette right here. Now, this WebSocket endpoint does a fairly basic thing. It is going to allow a browser or any other device actually that is working with the protocol to connect to this route. And then if we send it data, it is simply going to respond to this data by sending text. Looking at the code is nice, but there's nothing quite like actually seeing this demonstrated. So I am simply going to say hello world and hit send, and you can see that instantaneously we get text that comes back with my text. Now, this is a silly demonstration, but you can read all about what else you can do with WebSockets down here. And what I'm going to do in the code is I'm going to go ahead and change this code so that this mimics the timed one-time password code. So this way, instead of having any sort of system that has to poll this endpoint to get new codes every 30 seconds, we will be able to build a JavaScript front end that will connect to the WebSocket and go through and then just receive the codes. Now, given that we just stepped through the code for the timed one-time password and that it is simply going to be almost virtually exactly the same code as what we saw on this endpoint, but now on the onReceive handler for the WebSocket, I'm going to forego stepping through that in the terminal. The code is yours to go through. It is very similar, and it will immediately demonstrate some of the power that WebSockets have, as well as how easy Starlette makes this, right? I have had to do almost no work to immediately gain access to a persistent connection. Before I go, however, I simply want to point out that the code that I used to generate that HTML page is actually found on Starlette's documentation. You won't find it on WebSockets. You will find it on the endpoints documentation. And if you scroll down, you can see I'm most of the way down the page. You'll see the WebSocket endpoint demonstrated, and all I've done is simply copied this out. So this HTML page is also included in the repository, so you can take it and run. And again, you'll find that after the commit that we have just stepped through to demonstrate WebSockets is a whole host of code that will show you how to program the time one-time password. But again, given that we've just stepped through it, we're not going to see it. With that, we have seen how easy it is to build both HTTP endpoints and WebSocket endpoints in Starlette. But now let's talk about what this means for Python and Django.